Hello, everyone. Welcome to today's MyForum session, which is focused on multi-cloud networking. My name is Bart Salat. I'm Field CTO here at F5 for the Europe, Middle East, Africa region, and I am your host for today's session. As usual, before we get started, a few housekeeping items. If you have any problems with the video, audio, whatever, if things stall, then just try to refresh your browser. Usually that solves the problem. If it still doesn't work, then maybe you may want to switch to a different browser. Sometimes that helps solve the issues as well. Very important, if you have any questions throughout this presentation, please submit them in the Q&A box that you see on your screen. I will be monitoring that Q&A box while our speaker presents. And at the end of this session, I will do a live Q&A with the speaker, trying to go through all your questions. As always, we would very much appreciate if you fill out the survey at the very end of this session, because that's really important for us and very valuable to help us do the right thing and improve our sessions even further in the future. So let's get into it. Today's MyForum session, we're going to zoom into a few real case studies on multi-cloud networking. And our goal is really to show you how this technology has helped customers solve entirely different business problems. And our presenter for today is Stephen Archer, who's solution architect here at F5. He's very experienced in this subject, and he has been actively involved in some of the case studies that you will see here today in the presentation. So with that, I'm going to hand it over to Stephen.
Hi, Bart. Thanks, Bart. That's much appreciated. Welcome, everyone. Thank you for joining. As always, yeah, we really appreciate you taking time out of your busy day to come and listen to us. So, as Bart mentioned, we're going to go through a few kind of common scenarios, kind of explain how multi-cloud networking actually functions, and talk about some of the challenges which kind of helps understand, I guess, why you might need multi-cloud networking. So the topics, we'll go through a kind of bit of multi-cloud networking background, talking about some scenarios, approaches, and challenges. And then we've got the actual case studies. So the first is interconnecting applications and securing APIs, which is a global banking case study. The next one is interconnecting cloud native applications. So this is a cloud provider case study that kind of focuses on connecting edge. And then the final one is enriching SD-WAN with multi-cloud networking. So this was a global telco case study that really helped them kind of increase their relevance in a kind of multi-cloud world. So first, to talk about some of the scenarios, approaches, and challenges, and really help explain what is multi-cloud networking, why do you need multi-cloud networking, and where and when can multi-cloud networking help resolve problems. So the common scenarios that we typically encounter, you can see on the slide here. There's one slightly less common scenario that I'll kind of mention as well, which is that some customers want to use multi-cloud networking just to kind of improve the kind of default networking tools that you would find in public cloud environments. But the more common scenarios really are where you've got at least two environments that you want to connect together, and usually those environments have kind of fundamental differences in terms of their networking capabilities and functions. The first really is data center to cloud. Now this comes about because, I mean, it's a journey that started, 5+ years ago, where customers were moving or starting to move applications out of server farms and into the cloud. And I mean, we really were worried about this at one point. We thought this was going to be a one-way street, where actually all of the applications were going to end up moving out of the data center into the cloud, and the data centers shut down. But the reality is that that has not happened, and there's a number of reasons why that hasn't happened. So many of the good reasons why customers wanted to move applications to the cloud still exist. There are specific capabilities in clouds that customer developer teams want to leverage. There's also reasons of the easy ability to scale. And of course, some customers are developing applications in the cloud, so born in the cloud applications as well. But some of the reasons why other applications remain in the data center rules of data sovereignty is a good example, where customers need to keep data on premises. But also, in certain industries like public utilities, airlines, banking in particular, they have a lot of their kind of core systems of record that operate on mainframe. And those mainframes are so reliable. They've been around for 40 years. They've got almost no bugs. They want to keep them in the data center. So you then have components in the cloud that need to pull data from those components that live in the data center. So when you've got this requirement of connectivity between cloud and data center, that's when multi-cloud networking becomes important. The second example is cloud to cloud. So some customers maybe already have connectivity from their data center to their cloud, but as they start to expand their clouds and create multiple clouds, so either because they've decided that a particular cloud has capabilities that they want to leverage for a new application or service, or as the result of a merger or acquisition, you can find yourself in a position where you're using 1, 2, or more clouds, in which case there will be components that need to communicate across clouds. And again, this is where multi-cloud networking comes into play. The final example is edge to cloud. So in this example, we've got applications that require either local processing in order to kind of minimize the amount of data transfer, because there are huge volumes of data to transfer, or low latency requirements where the speed of the response is really important. So an example of kind of low latency requirements, I'm kind of working with a customer who is considering pushing their application into their customer location. So their customers are a certain type of financial services institution, and they're looking to speed up transactions for their customers. Other examples are, in gaming, for example. But the more common use case really is where we've got local processing requirements in order to minimize the amount of data that's transferring from the edge to a central location. So some examples that we've seen here are in retail, for example, where retailers are monitoring footfall within the retail location, so measuring how many people are in the shop at any given time. So they can monitor video feeds, and they can actually analyze right there with an application using AI how many people are available, are in the store, and actually just send metadata back to the central location. So describing, there's 3 people, there's 4 people, there's 20 people, rather than sending the entire video feed back to the central location. If you kind of extrapolate that hundreds of times in hundreds of retail locations, then the bandwidth required, the amount of data transferred, and the capacity required to process it centrally becomes unmanageable. So there are, broadly speaking, 2 kind of multi-cloud networking solutions. The first of those is a kind of network-centric approach, which really is trying to redistribute routes and open connectivity between locations at layer 3. And this is done with a kind of layer 3 VPN fabric, so an overlay network that would connect these locations together. In each location, you would have a software networking component that is learning routes, either directly connected routes or learning routes through BGP peering. And then you are choosing which of those routes to redistribute across the network, and therefore allowing components in each network to communicate with each other at layer 3. Now, just layer 3 connectivity in itself is not enough. We need then to layer on security. So typically you would see layer 3 and layer 4 firewalls actually becoming part of this solution. And the second approach is what we call application connectivity. So this is an application-centric approach that builds on top of the network-centric approach and builds in layer 7 functionality. So using load balancing and proxy technology to discover applications that operate in one location and make them available and make them appear as though they exist in actually a completely different location. So this actually is a really kind of important advancement on multi-cloud networking. And if you think about even the network connectivity approach, fundamentally what you're actually trying to do is to connect applications. So there's a lot of good reasons why the application connectivity approach makes sense. Now, in order to achieve either of these solutions, a multi-cloud networking capability really needs to be cloud agnostic. And that means that wherever you kind of drop this software multi-cloud networking component, it needs to understand the environment that it's dropped into, and it needs to be able to automatically program the cloud native constructs in order to enable routing, but also security and other components. It needs to be centrally managed, and this usually means decoupling the software components that actually operate the network with the control plane and operating the control plane centrally. Obviously, in order for it to be easy to use, it needs automation as part of it. So being able to automate the configuration of the cloud native components. And also, in order to allow customers to actually automate the deployments, it needs an API. So this is, I guess, the kind of key components of multi-cloud networking. So next, we'll kind of talk a bit more specifically about the F5 solution. So we start out with a global network. So F5 is actually a tier 2 telco. It's a network that we operate. It's a physical network, and this physical network, of 17 terabits plus, which was designed for mitigating, massive DDoS attacks. It's actually connecting all of our POP locations, and our POPs are physical POPs. They exist in tier 1 colo facilities. Often you will find that they're Equinix. And in each of these POP locations, we run the F5 distributed cloud software stack. So this software stack is an extremely comprehensive stack of services that comprise sophisticated virtual routing, the ability to create overlay networks and site-to-site VPNs. It also includes firewalls, so layer 3, layer 4 firewall. It includes layer 7 firewall, including API security specifically, and also load balancing. And then in addition to that, we have DDoS mitigation and CDN and some other capabilities besides. So if you wanted to make a service available to public users, then you can do that from the F5 global network. That's one of the options. So public users can come into a globally available instance of your application. We can provide automatic creation of DNS A records. We can provide automatic creation of TLS certificates and keys, and then provide all of the security that you would need for your application. And then we look at how does that global network then connect to the environments where your applications are deployed. So the first example here, we're deploying the F5 software stack. It's exactly the same software stack that runs in the F5 global network. So the software stack that's running in the public cloud is actually a sophisticated router, it's a firewall, it's a load balancer, it has all of the layer 7 security, so API protection, bot protection, and web application firewall. But also, the global network is not just a data plane, it's actually a control plane as well. So we have a control plane. The whole thing is SaaS, so it's delivered as SaaS. So we operate this control plane. The control plane is API first. So everything that all of the components that are deployed can all be controlled by API. So there's 100% coverage with our API. So the global controller can zero-touch deploy the software stack into your public cloud. So behind the scenes, we use Terraform to actually do that deployment. And Terraform can then also create all of the other constructs within your cloud. So the Terraform solution obviously understands AWS, it understands Azure, it understands Google Cloud and others. But it means that we can deploy the software stack into that cloud and program the public cloud network constructs themselves in order to fully end-to-end enable this application connectivity. So in this example, the global controller is actually automating the creation of transit gateways, all of the security groups, the routing and subnets, and so on. In the next example, you can deploy the same software stack into private cloud. So it can be deployed as a bare metal installation on common off-the-shelf hardware. It can be deployed as a virtual machine, but it can also be deployed as a Kubernetes deployment inside Kubernetes environments. I mentioned that the global network is both a data plane and a control plane. But actually, the data plane is optional. You don't need to use the global network as a data plane. And we can create tunnels directly between locations. So in this example here, you can see we've got a site-to-site tunnel created between the private data center and the public cloud. So we can create any kind of networking architecture really that you would be interested in. So hub and spoke topologies, where the tunnels are created automatically. You just select which sites should be involved in the hub and the spoke. In fact, one of these software stacks can actually be a hub in one topology and a spoke in another. And we can create really interesting network topologies that way. The next example is again public cloud, but this time using ExpressRoute and Direct Connect. So if you don't have your own, you can actually use F5's ExpressRoute and Direct Connect in order to connect public clouds to other environments. The next example is SaaS providers. So one of the capabilities in multi-cloud networking that I've not explained yet is the idea of forward proxy or dynamic reverse proxy that will actually allow other components in the network to reach these SaaS providers. And the global network that we have is actually paired with over 4,000 other networks, including SaaS providers. So we have very, very good connectivity. The last example is Edge. So again, being able to deploy this software stack in a really small form factor for deployment into edge locations. So, these could be, retail locations, they could be manufacturing sites, they could be, large infrastructure projects, like building a power station or something in a remote location. It could even be on public transport. So, it doesn't necessarily need to be a static location. But essentially, wherever you deploy this software stack, it will automatically connect itself over any available network back to the global network. And of course, surrounding all of this, you need centralized operations and visibility. So having a solution where you can have all of your users log in using single sign-on, full role-based access control, being able to see what's going on end-to-end, so having that visibility, analytics, and then intelligence as well that we can bring to the system using AI and machine learning to really highlight kind of business benefits from the data that we're collecting. So some of the challenges around connecting multi-cloud environments if you don't have a multi-cloud networking solution. The first of these is complexity, and we've kind of touched on some of this already, but if you think about the way that you need to configure each environment in order to connect it to another environment, the networking in each public cloud is completely different. So for example, in AWS, if you look at a deployment across availability zones in AWS, each availability zone is a separate layer 3 network, right? So you kind of have to have kind of routing between them. In Azure, it's completely different. It's a single layer 2 network that spans availability zones. So each cloud is different. And of course, the data center itself will also be different. Resourcing and expertise is another challenge, because you would need specific expertise, a deep level of expertise for each cloud environment that you're going to operate in. And finding talent that actually can do, or rather has the deep level of skill across all clouds and the data center and private cloud, it's nigh on impossible. There are very, very few people with those skills. Network uptime and reliability is another major problem that customers are contending with. So, if you think about, I mean, we talk to customers all the time, and they really trying to follow individual connections to their applications from end to end. So think about how you do that in your organization. And I'm pretty sure you're not doing it, because I've literally never spoken to a single customer who can actually do this. So think about tracking a connection that comes in on a public IP address, hits a firewall and does some address translation. That firewall, the external router, can send logs and analytics to a central repository like Splunk or Seam or whatever. But as it passes through the firewall, the addresses translate. And then maybe you're hitting a load balancer or a proxy that again is doing address translation and breaking that connection out in one of multiple different paths to different application servers. And then the server itself is using different logic to initiate connections to other back-end services. So trying to understand a single connection end to end is incredibly difficult. And you may as well say that it's actually impossible. So business agility is another major problem. So, developers became au fait with automation really long before NetOps and SecOps did. And they're moving at lightning speed. Really, networking hasn't really kept up. So automation becomes a really key factor in trying to bring this agility to network and connectivity. And then different environments. So differences in the different cloud providers' services slows you down. It also increases errors and therefore risk. And it also has another problem where, and we've come across this with a number of customers, where because a particular cloud provider maybe has moved into their business and become a competitor, they've made a decision to move to a different cloud provider. But they then find that they're deeply kind of locked in, so the roots of their applications have gone deep into that particular cloud, and they sort of struggle to move any services around to different cloud environments. So having the ability to do that, to move applications simply and easily, is highly necessary in many organizations. And the final part here is security. So consistency of security policy is a problem on multiple levels. At the simplest level, if you've got two different security solutions, they're not the same. So where one may protect you, the other actually may have a vulnerability. So we need consistency for that reason. Secondly, you need consistency because in the event that there is a major vulnerability, for example, Log4j, if you want to answer a simple question, where am I exposed to this vulnerability? Where am I not protected? If you've got a myriad or many different solutions, answering that question takes considerable amount of time. So we really need to make sure that we have consistent security across all of the environments. Now, another part of this is our customers are telling us that security teams are struggling to get on top of understanding all of the security components of the different cloud environments. So again, bringing consistency is really helping the SecOps team as well. So let's talk about the first case study. So this is a global banking case study, and the goal here was really to interconnect applications and APIs and secure them. So you can see here that we've got a number of data centers and a number of public clouds with application components spread across them. And the application components need to leverage each other to pull or push data around. And the challenges and requirements that were presented to us were that they wanted to interconnect these applications across private data centers and public clouds. So we're not just talking about existing or pre-existing applications. We're talking about actually deploying hundreds of new applications, right? So this is a picture that's actually evolving and growing and becoming more complicated. They wanted to be able to protect these distributed applications on both the web front end, so the north-south traffic into the front end of the application, but then also the east-west traffic, the back-end interactions between all of the application components and APIs. And they needed centralized visibility, obviously, for and for their operations teams, for both the networking components and the security components. And then the major requirement really was that they wanted to achieve all of this in a self-service model, so that the developers could log in, choose what they wanted to do. I've got an application here, it needs to talk to an application in a different location, and have all of these components fully orchestrated. So the initial solution that tried to address the problem actually centered on deploying two on-ramp locations. So the idea of these on-ramps would be that they would kind of connect to the existing WAN of the organization. So the first thing to do, obviously, is actually connecting those on-ramps to that existing network, and then actually procuring direct connects, express routes, interconnects to all of the public clouds. That obviously is an expensive undertaking. Then it starts to get a bit more challenging, right? So then trying to build an orchestration solution that could orchestrate all of the necessary routing, so redistributing the routes from each of the clouds, implementing layer 3 and layer 4 security, so trying to service chain in firewalls, and maybe other solutions as well, deploying proxies and load balancers, and this is twofold. So partly to support the applications, but also to support the infrastructure in the colo itself. So that colo would obviously need to scale as the number of applications passing through the colo would grow. So there's that aspect as well. And then of course you've got the layer 7 security. So deploying WAFs and API gateways and so on. Now, all of this activity is horrifically complicated, but then you realize that actually that's not the end of the story. You then also need to orchestrate the deployment of new cloud environments themselves, adding to the connectivity, so orchestrating the routing, orchestrating the layer 3 and layer 4 security constructs within the cloud that could be third-party firewalls, also security groups in the cloud itself. And as you probably know, they operate in very different ways, some stateful, some stateless, and so on. Proxies and load balancers that are supporting the applications themselves, and then also other layer 7 security components. Now, all of the different clouds operate in completely different ways, so the orchestration solution needed to address those differences. And then on the data center side, you've got different generations of data center. So some kind of traditional data centers, some newer data centers with private clouds. So again, having all of this kind of orchestration was incredibly difficult. It was incredibly expensive, right? So if you wanted to connect data centers and clouds and having to procure on-ramp locations for that, all the costs of the circuits and everything else, not including the project costs, all the skills necessary. It's complicated, right? I think I've kind of described how complicated this undertaking was. It's incredibly time-consuming. So we're talking about multiple years of effort, and ultimately unsuccessful. So it was too difficult to achieve. So this is where the chosen solution comes in. Actually, you can see immediately the simplification of the solution using F5 Distributed Cloud. So the solution in this case actually took 2 weeks to prove. Most of that time was actually obtaining the credentials to allow us to deploy into the public cloud environments. But in a sense, really very simple to deploy. So once you've got the credentials, the global controllers deploy the software stack into the public clouds, zero touch, so it's automatically done. Creating the cloud environments, including VPCs, VNets, the subnets, the routing, all of it done. And then actually, even though all of that stuff is done, the whole fabric that you can see represented by this dotted line is default deny. So none of the applications can actually talk to each other at this point. But then creating load balancers and web application firewalls and so on is a really simple process. So for example, if I want the application in the data center to communicate to the application in AWS, the developer can log in into the global controllers, to the UI. They can self-service credentials, so create their own API credentials. They can use those credentials to then create the load balancers and pools. And the load balancers and pools can actually span multiple sites. So in an example, the load balancer is created in the data center, and the origin pool is configured in AWS. So now the app in the data center talks to its local load balancer. All the layer 7 controls and security is done at the data center, and then the connection proxy across to the AWS environment. So you're able to expose services in locations specifically where you want them. So you can do this kind of application to application connectivity with surgical accuracy. Really, really simple. So the key capabilities here were that we could interconnect the applications across private data centers and public clouds. We could protect the distributed applications on both the web front end and the back end APIs. We enabled a centralized visibility and operations for networking and security. And we could provide the end-to-end self-service orchestration that the developers were looking for. So the next case study is actually a public cloud provider. And this solution really allowed them to interconnect cloud native applications across the cloud and edge locations. So the business problem was that they needed to connect a distributed and cloud native edge application with a centralized MongoDB database. Now, this is an example, right? The actual use case was applicable by this cloud provider to all of their customers. And this is one example that kind of illustrates the case. And the solution also needed to provide seamless Kubernetes experience to the application teams and abstract away the underlying network complexities. So you can see the two lines here, and that kind of illustrates the point that when you deploy an edge solution, and I've given some examples on the left there, so there are many of them to choose from. But when you deploy them, they don't natively include the connectivity back to cloud environments. So you kind of have this chasm between the two. So you need a solution to be able to make this connectivity work. And that's where our solution came in. So in order to solve this problem, we were able to make the MongoDB that's running in multiple environments, make it available to the edge clusters regardless of where the MongoDB was actually running. So from the edge applications perspective, they talk to a local VIP inside Kubernetes. So they talk to a Kubernetes service. And that Kubernetes service is connected to the F5 software stack. And that software stack is providing the layer 7 security and connectivity and able to proxy chain that connection across to the cloud environment where the MongoDB is running. So it would send the edge location to the closest location with the MongoDB. And then in the cloud environment, the software stack there would actually monitor the health and availability of MongoDB and also deliver the requests to MongoDB and send the responses back. So in both the edge and the cloud cases, the deployment is done using Kubernetes. So in terms of advantages, it actually meant that there was no need for additional hardware appliances. So all of the deployment is done inside Kubernetes cluster itself. The third use case is enriching SD-WAN with multi-cloud networking. So this is a global network operator, global telco case study. It is a really interesting use case, actually. So in this example, and of course, the SD-WAN and MPLS connectivity here could be between any two locations, right? It doesn't have to be AWS and Azure, as my example shows. It could be many different environments. But the SD-WAN provides connectivity, very simple connectivity to different clouds and locations. But it doesn't do any of the networking functionality, or doesn't configure any of the network functionality within the clouds themselves. So the provider themselves kind of describe this as, we're seen as just a dumb pipe that connects the two environments. But it really needs a solution that kind of harmonizes the networking operations and simplifies this application interconnectivity. And that's the part that they really struggled with. So the network operator, or telco, really only provides that kind of middle piece. And this really jeopardizes their future business, because customers are starting to wonder, well, what is the benefit of the solution that they're providing for us? So in the way that their customers were currently doing it was that they were having to self-manage all of the other connectivity components. And again, many of their customers were saying that they couldn't find the expertise to do this. So there's real opportunity here. And this is where the F5 solution comes in, is that the telco were able to kind of extend their reach into the customer environment. So beyond just the simple SD-WAN connectivity, and then being able to program all of the cloud constructs to enable application-to-application connectivity. So the solution solved their customers' challenges via the automation that the F5 distributed cloud platform brings. And this allowed them to reduce the time to connect apps from 6 to 10 weeks of the customer passing tickets from team to team, from the network team to the security team and so on, all the way down to a couple of hours. So huge, dramatic improvement in time to business. And the second part of this is really expanding the control just beyond the simple connectivity and offering a solution that is truly end-to-end. So now the customer can just focus on applications and they can hand over responsibility of all the complicated networking to the telco. So in summary, we've seen three individual success stories. So the first was allowing the customer to interconnect and secure their applications and APIs across all of their locations, enabling individual applications to connect to each other. And if you think about it, almost creating an individual service chain. So allowing an application to talk to a load balancer with a web application firewall, with all of the routing and connectivity to the remote application. So creating this end-to-end service chain, fully automated with end-to-end visibility. The second example was a similar solution, but connecting specifically edge environments and done in such a way that all of the multi-cloud networking software was deployed inside Kubernetes, so deployed as Kubernetes pods, and still being able to interconnect applications and making a MongoDB database appear as though it was local to an edge cluster. And the final example of enriching SD-WAN, so allowing a global telco to augment a traditional SD-WAN solution and increase their reach and value into their customers' networking and cloud environments. So just to end on three key takeaways that are relevant to all three of these solutions, and in fact, any multi-cloud networking solution. So the first is that we can securely interconnect applications and APIs no matter where they're deployed. We can streamline application interconnectivity with simple end-to-end orchestration. And allow you to gain insights with end-to-end visibility and analytics with no configuration required. So with that, I will finish and thank you for listening, and yeah, hand over back to Bart.
Thank you very much, Stephen. Yeah, very interesting to see how this technology of multi-cloud networking is solving different business problems for different types of organization, right? You had an enterprise use case, a banking use case, you had a cloud provider use case, which was a very application-centric, focused on application developers, right? Making services look like they're local. And then you have the service provider telco use case where multi-cloud networking is a tool to enrich their, let's say, traditional connectivity services and help them go up the value stack. So yeah, interesting to see that combination of different use cases in one presentation. Thank you for doing that. So I've been monitoring the questions a little bit. So let me get started with the Q&A. And yeah, to the audience, please don't hesitate to add more questions. I will keep on monitoring them while Stephen is answering some of these. So okay, let me go to the first one here. So you mentioned using AWS Direct Connect, Azure Express Route, GCP Interconnect. I wasn't sure if you meant that we, as the customer, would need to buy and provision these circuits first.
Okay, well, the simple answer to that is no, you don't need to. F5 actually has pre-provisioned all three of these. And they are connected to the F5 global network. So we can actually help you connect to your clouds using our connectivity. So if you have, for example, a data center and you want to connect it to your cloud, you can drop the F5 node or distributed cloud node software stack into your data center, and it will connect itself back to the F5 global network, which in turn is connected to all of the clouds. So through simple automation of our platform, that can enable connectivity to your cloud environments. And therefore, we've basically given you connectivity from your data center to your clouds via our network. Now, if you have your own Direct Connect Express Route Interconnect, you can use those, right? Our networking constructs will overlay those. So actually both will work. So either buy your own or use ours.
All right, thank you. There's a couple of questions which probably relate to the fact that, yeah, you explained that we have the F5 global network, and then you started diving into how some of that software can be, let's say, deployed and run on premises. And I think that has generated a couple of questions. The first one on that is, how can the F5 nodes in the cloud, AWS, Azure, etc., provide the security if the data path is not via your global network?
Well, I think you kind of hinted at the answer there, Bart, that it's the same software stack. So if you think about it, the software stack itself is it starts out as a router, so it will speak BGP, or it will be at the end of a static route. Doesn't really matter. It is then a load balancer. It's a layer 3, layer 4 firewall. It is a WAF. It will handle the bot mitigation. It will do API gateway security functions. So all of these things are kind of baked into that software stack. So when we deploy this software stack into a cloud or into a data center, you can kind of think of it as a DMZ in a box, because it has all of the security components that you would typically find in a DMZ. And yeah, of course, that software stack is connected back to the F5 global network control plane. So it can still leverage some of the AI and machine learning of the kind of that sit in the F5 control plane as well. Does that answer the question?
Yeah, I
There's a
think it does. I think it does. But I think there's another question related to this, which is about how can you how can you call this a SaaS service when you deploy something on-prem? And I think that is for many people a bit of a strange concept, right? To have a SaaS service, but you still need to deploy something on-prem. So could you elaborate a little bit on that?
Yeah, sure. I mean, this software stack needs to be deployed on something, right? Whether deployed on bare metal or virtual machine or inside Kubernetes. So, you know, the environment that you deploy it on, we're not necessarily managing that, but we are managing the software itself, right? So, if you deploy as a virtual machine, for example, when you deploy the virtual machine, it's a very simple deployment, and the virtual machine, once it's booted up and running, it connects itself back to the F5 control plane and hands over responsibility to the control plane. So now you as a user, you log into the F5 console, which is SaaS. So the console is operated in F5 locations, totally managed by F5. All the software that runs there is also managed by F5. So as we kind of provide improvements and upgrades and new features, they are all automatically appearing in the console. Now, because the control plane operates there and it's controlling that virtual machine, it also means the control plane can upgrade that virtual machine. So again, the upgrade process is very simple. You log into the SaaS console and you just have an upgrade button. And that will go off and do a kind of rolling upgrade, sort of modern upgrade procedure of that software stack that's running on your virtual machine. So that's really how that works. And in public cloud environments, it's much more in F5's control. So we actually will do the full deployment of the virtual machine in a public cloud environment, as I mentioned, right? And we can orchestrate all of the cloud environment components. So you can literally start with nothing, and we'll create a VPC, we'll create routing, we'll create subnets, and deploy the machine and stitch everything together. So in that sense, it really is a SaaS solution.
Yeah. So is it fair to say, Stephen, that when you deploy this piece of software in your cloud, in your private data center, the only time you would, let's say, touch it locally is when you need to give it a token to register itself to the F5 console. But after it has registered itself, you will never, ever communicate directly with the instance anymore. You will always go through that SaaS-based console. Is that a good understanding of how it works?
Yes. I mean, that's typically how it would work. Now, there is local access to the machines with a kind of like a limited console for troubleshooting purposes, but that's really it. Otherwise, yeah, everything is done via the SaaS console. Okay. Even, for example, you want to run a TCP dump, right? Which is something that I know many F5 engineers and network engineers want to do. You initiate that from the SaaS console, but the TCP dump itself is actually running on the software. Sniffing packets on the local network, and then it's presented to you in the SaaS console. So, there's many other troubleshooting tools like that, but yeah, everything pretty much is done via the console.
Yeah. Okay. And I think what you just described is probably, partly answering the next question, which is about, how is the F5 solution different from, let's say, other SaaS-based security solutions on the market like Cloudflare, Akamai, etc. Right? Would you agree that this ability to deploy the software locally in your customer environment is the big difference between what we do versus what they do?
Yes, absolutely. I mean, there are differences in the security efficacy of our different offerings. And the key difference, as you said, is our ability to deploy the software stack anywhere. So we obviously have a number of POPs where we operate the software stack, and you can use just that if you want. you don't need to deploy the software stack in your environments if you don't want to. But most customers see the advantage of being able to do that. So you can think about it two different ways, I think. One is that you can use this software stack to increase the number of POPs. So F5 already has 26 POPs and growing. But there may be a requirement to add a POP in another location, and the software stack allows you to do that. So you're just increasing the number of POPs. So you could have an infinite number of POPs if you wished. But they can also be used to create kind of internal POPs, right? So we've talked about using these software components to connect applications together in the environment, but they really are just internal POPs. They're private POPs, and that's another way to think about them.
Okay, great.
Yeah.
Thank you. There's a question around performance. What about the performance, scalability, etc., of these VMs that include load balancing, WAF, etc.? So I guess the question boils down to how can we scale this if you start deploying, let's say, software-based instances in customer environments?
Yeah, so because actually underneath the hood, they are Kubernetes, right? So we scale in the same way that a Kubernetes cluster scales. So we start out with, you can run a single node if you wanted in a single location, or more typically you would run a 3-node cluster, so 3 master nodes, and then you can scale out to any number of worker nodes. So we've deployed this and scaled up to huge numbers of nodes, and of course, nodes clusters constitute one deployment in one site, one location, and obviously you then scale this out in terms of sites. So you can have big clusters in any number of sites, and we've tested to hundreds or even thousands of sites. So it can scale massively. So one of the kind of key key advantages of the solution is that if you think about the way that application delivery and security has been done traditionally, it's kind of centralized in one place. So you attract all of the traffic into this place where you have the application delivery and security, and that then forwards requests to the application. But now we can actually break that application delivery security up and distribute it to the edge. So that can be in the F5 POP locations, or it can be in your edge locations. It doesn't matter, but we're kind of distributing the kind of heavy workload of application delivery and security and spreading it about. So I think that really helps. But in public cloud, for example, scaling is very, very simple, and you just specify the number of nodes, and that's it. That's all you have to do. Very, very simple.
Okay. Great, thank you. I think looking at this, I think we have time for one more, Stephen. I want to be respectful for everybody's time here. So let's go for the last one. On one of the slides, you showed a bunch of vendor logos. Can you please explain again what role they play in F5's multi-cloud solution?
I guess that would have been the cloud provider example, right? With all of the edge solutions?
I think so, yeah. You may want to bring up that slide again if we can. I think it's this one.
Yeah, this one. So yeah, basically, we're just showing examples because this was obviously a specific cloud provider, and we can't share which cloud provider this was. So we're just showing examples really on the left of all of the different cloud providers' edge solutions. that's really what those are. So we wouldn't expect customers to deploy all of those different edge solutions. I guess you would probably have one, or maybe two, and we should actually say as well that F5 actually has an edge solution. So those little red Lego brick software stacks actually can deploy Kubernetes applications as well. So in actual fact, you could just deploy F5 and that would be an edge solution. But these are just examples. So hopefully, I may have missed part of the question, so I don't know.
No, I think that was the crux of the question. Okay, great, thank you, Stephen. That's all we had time for today. I want to be respectful for anybody's time. For any questions that we didn't get to, we'll contact you directly via email. And with that, we will conclude this My Forum session. We'd like to thank you once again for joining us today, and I would like to specifically thank Stephen for his engaging and insightful presentation on multi-cloud networking, and for answering all your questions, obviously. If you haven't done already, please take a moment to complete that brief survey that will pop up when we end this webcast. Thanks again for being with us today, and see you next time.